right, so here we are doing ED301. This is where we'll look at the stack protection in the assembly code. So for this, you need Visual C++ build tools. If you're using the machine from my malware analysis class from last semester, all this stuff is already installed. But if you haven't, then you'll have to install it, and I have some tips here how to install it. And yes, I'm using Proxmox. Proxmox is a Debian-based Linux distribution just to make a private cloud, and it's very nice. You install these machines, and you can launch them through a web browser, so you don't need to use remote desktop protocol or anything like that, so it's very nice. So here's how you can install it from Microsoft. If you have Visual Studio, then you already have it. So you can make a program with a possible buffer overflow. One thing about this, though, is you have to use this thing called a developer command prompt, and it's often confusing to students to load it. So this is a weird thing about Microsoft Windows. If you want to develop code, command line code in Windows, you have to do this. You have to go to the Start button, and you have to find this list of programs, which Microsoft keeps hiding and making harder to find. It's harder to find in Windows 11. And using that list of programs, you have to find your Visual Studio that's installed, and then expand this folder. And now you have a bunch of command prompts to launch, and you have to launch the right one of these command prompts. You can't just use a normal command prompt to compile code for some strange reason. And there is no malware analysis class this year. It was last semester, and might be next semester, but I don't know yet. So this is the one you want, Developer Command Prompt for Visual Studio 2019. You open this, and now you have what looks like a normal command prompt, but you have to do it this way or you won't be able to use the command prompt tools. I don't really understand why you need a different window, but that's the way it works.
Probably set up different environments.
Yeah, I'm thinking it probably sets up environment variables. Anyway, you don't need to work in that directory, and I made a folder according to the project instructions called CD127, and I think I'll try and make the font bigger for the video. It's actually already pretty big, but let's make it Lashida bold. Bold, I say. All right. Unable to modify, that's all right. All right, all right, so now I can do a dir. I've already created some code here. And so let me get to my instructions, which will be here. Okay. All right, so it's test. This program is called pwd.cpp. So yeah, I can open it with, let me move this up so it doesn't vanish from the screen for the remote viewers. All right, so Notepad, pwd.cpp. All right, so here's the program, which just has a test PW routine with an overflow, a pin with 10 characters, and then it inputs using cin, which is unlimited, so you can have network buffer overflow in it. That's all. A simple program. All right, and when I get to my instructions, which are here, so now you compile it. And what you do is you copy the same source code to another one with just pwdn, and then you compile. CL is the compiler. The EHSC switches, I don't remember what they do, nothing important. Without any special switches, it'll compile with a stack protector. But if you add the /gs minus switch, it'll compile without the stack protector, and I've already done this. So if I go here and do a dir, I've already done a dir. Let's do dir of */exe to make it more clear. There, and now you see here's pwd and here's pwdn. So pwd is 204,288, and pwdn is 203,264, about 1,000 bytes smaller. And if you look at them, now I think we're going to compile them. Let me see if I can get to the instructions. All right. Now we're going to use IDA. All right. So we launch IDA. IDA is a free program, a disassembler for Windows that we use. IDA freeware will work for this because we're making, I guess we're making 32-bit code, actually. I don't think IDA can do 64-bit code. So you click New to disassemble a new file, and now you find your program. So if I do pwd here and disassemble it, it's going to ask for options to disassemble it and just use the default options. and it disassembles your code and shows it to you. Now, one thing about all debuggers and disassemblers is they don't take you to the real start of the program for some reason. It's an irritation. This is some kind of start, but it's some kind of internal Windows processes, not the part of the code that actually is related to the code we wrote. So to find it, the best procedure I've found is to use the strings. We know if we run this program, if you look at the source code, you can see what this program is going to do is ask you to enter a password, and then it's going to either print fail or you win. So this string enter password, that's something that happens in the code I wrote, and I want to get to that area. So to find that, you click View, Open Subviews, Strings. And the strings appear, or so I thought. Oh, they're down here. Okay, they didn't open in a separate window, which is a little screwy. But anyway, here they are. Here's enter password. That's a strange thing in IDA Pro. Normally it opens in a separate window. Window, strings. All right, somehow I've docked this window, or maybe I just need to drag it. Oh, there we are. Okay. It is a separate window. Somehow it appeared in a funny part of my screen. So here's the strings. And you see right at the top, the enter password string. So once you've found that, I know this is the part of the code I want to see. So I double click that, and that will take me, let me close this strings window. That will take me to that string, enter password. This is not in a code section though. This is in an R data section. So this is where the string is stored. Now if you want to see the code that uses the string, you point over to the right on the data.xref. And when you hover over here, a box will pop up showing you some of the string, some of the code that uses it. And if you double click over here in this address to the right of data.xref, it will take you to the code that uses the string. And now you can see what I came here for. You can see here it is setting up the stack frame, saving the base pointer, and moving the stack pointer to the base pointer and subtracting from the stack pointer to create a stack frame, and then putting a security cookie on the stack. So you can see right here, when it enters the function, it's putting on a security cookie. And if I scroll down to the bottom where it comes back, we should be able to see when it's done with all this and it's time to return, down here somewhere. Yep, here it is returning, but before it returns, it calls this security check cookie. So you can see the code that implements the security cookie protection. And if you examine the other program, I'll do File, Open, and don't save the old one, and open pwdn.exe that we compiled with the gs-switch. And if I just do the same process, again, it puts me somewhere stupid, so I have to do View, Open Subviews, Strings, and then go to the Enter Password string, and then go to the data.xref, which is the code that uses that, and double-click that, and now here's this one, and here it sets up the stack frame and just prints Enter Password. It does not put a cookie on the stack, and if you scroll down to where it returns, of course, you're going to see just what you expect here. Here it is ready to return, and it just returns. It doesn't bother to look for a cookie value before returning. So this is the unprotected version of the program. All right, so that's the first part of this project, and I think there's more. I'm going to, again, not save the database because I just wanted to look at that program. I don't want to do any extensive analysis of it. All right, so that's IDA free. And I guess that's it. Okay, there's a couple flags to find there. So that's it for ED301, and I'll stop this recording.